Hey, ZKast here from ZK Research. Where am I, you ask? Well, I'm outside the Expo Hall at AWS reInvent 2023 here in Las Vegas. AWS reInvent is one of my favorite shows of the year because it's packed with innovation. Now, I can't go in the Expo Hall and show you all the innovation because the Expo Hall is massive and it's filled with people. But what I can do is go ahead and go in and show you some innovation, maybe 4 or 5 stations. So let's go in the Expo Hall, have a look, and I hope you enjoy the ZKTour. Okay, well, I'm inside AWS Village. I'm with Cass Santos.
Yeah.
I actually stopped by the generative AI solutions area first, which makes sense given how big generative AI is.
Yeah.
And as your badge here says Party Rock, what is Party Rock?
Yeah, Party Rock is this application that runs using Bedrock, and it's a great way, it's a playground. It's a great way for you to show people how generative AI works and also let them create their own apps. And they can share with their friends and everything. And it's a first contact to people understand the power of generative AI. And as it runs using Bedrock, we can also show them how secure it is to have this environment to run an application using Bedrock. And also, probably they can show this to their customers if they don't know about generative AI and can give ideas of how to work with that.
So for those who don't know what Bedrock is, can you explain what Bedrock is?
Okay, Bedrock is this environment that can run several different models, foundation models, including Thailand. And this environment is a secure environment that runs on a secure cloud environment. And you can build with a few lines of codes a full solution using foundation models inside Bedrock.
Okay, and one of the things I like about Bedrock is it's not just AWS models. Right? You
exactly.
use Anthropic, you use Meta, there's a whole bunch of them in there.
Exactly.
And in fact, I talked to some customers that use it, compared to something like OpenAI, because they want the choice of models. As most people now understand that there won't be one model to rule them all.
Exactly.
Yeah.
You can choose by these several models, and also you can have this balance between cost and performance. And choose the best model that fits your solution.
Okay, well, this can't be Party Rock in name only. You're going to have to show me the demo. You ready to do that?
Exactly, this is the fun part.
Okay. All right, Cass, well, the demo freed up, so can you show us how Party Rock works? Let's party on Party Rock.
Yeah, this is the fun part. So, for example, we have some examples here that we can show you, but you can create your own app. This one, I like this. I like this one, podcast generation.
Podcast generator.
Yeah, so you just give here a topic for a podcast. Like, for example, let's talk about Bedrock. So I can come here and Bedrock.
Okay.
And it's already creating the app here. Or, sorry, running the model. So you can see this particular app have a description of the topic Bedrock. So you have here 2 hosts that were created like chatbots, so you can interact with this. For example, sorry about that.
And so all you typed in there was Bedrock. And it created all that content for you.
Yeah. This is an application that is ready, but I can create my own. And this one just created this with images, with 2 simulated hosts, and the background history for each one. And then you can ask your questions. Here we have some examples of questions, and you have the 2 chatbots, one for each of the hosts, and you can ask questions for them. And depending on the background, they will give you the answer related to their background. So this is an example of something that is already here. But suppose you want to create your own, so you can come here, build your application, and let's say, let's create one pretty simple, like to choose restaurants around. So, all right, let's choose the best. Choose the best restaurant around. Yeah. And I click here, and it's creating the app. So it's using Bedrock to select a model, to create the widgets that we are going to see in a minute. Once it's ready, we are going to see how it works to work with generative AI like this. To access, for example, let's decide on a restaurant. So they are asking me to put a location. So let's say
Las Vegas.
Las Vegas, of course.
Yeah. How is it going to pick the best one of all the ones here?
Yeah, and cuisine, let's say.
Sushi.
Japanese, sushi, okay.
Yeah.
Sushi. sushi. Okay. And then here is your answer. And it's pretty quick, right?
Yeah.
Also. And here you have recommendations for good sushi restaurants. And also you have a chatbot that you can ask more questions, refine your search and everything.
I haven't been to any of those restaurants.
Oh yeah?
Yeah, now I gotta go.
Oh yeah. I'm going to choose one here too.
Okay, well, dinner's on you tonight.
Yeah.
Anything else you want to show?
No, and that's it.
Okay.
You can use, and this is the best part. Once you create this, you can come here and you can share with your friends in your social media this app. So you can create the app and you can share with your friends and have fun, and they are going to understand how generative AI works.
So most people were kind of scared of building apps.
Exactly.
And if you're not a technical person, now anyone can build an app.
Exactly, without any code.
Yeah. All right, Cass, well, that was fascinating.
Oh,
thanks very much. So,
thank you.
Thank you. So party on and party rock.
Yeah.
Thanks. Okay, we're here now at the drone inspector station. I'm here with Joseph Bain.
Hello.
It's a pretty cool setup behind me. It's got a bunch of cages here. What are we looking at here? What is Drone Inspector?
All right, so what Drone Inspector is a showcase of AWS capabilities on the edge using generative AI. So right now we are using a large language model which is deployed in AWS local zones right here in Las Vegas, and it is essentially acting as a translator between human speech and machine language that the drone can understand. So what that means for me and all our players here is that we'll be typing in commands into a chat-based interface, and then that will be sent to the large language model, which would then translate that into a program that can be executed to navigate the drone about the map.
Okay, and since it's an edge use case,
Yeah.
You said it's a local zone, but is there what's the AWS infrastructure? Is there a structure?
Yeah, so essentially this is all using containers. So our large language model is containerized, and we're using Amazon Elastic Container Service, Amazon ECS. So we have some ECS containers that are deployed here on Raspberry Pi instances for things like live streaming and web applications that we see at the front for things like the video streams as well as the leaderboard, but also our large language model is also deployed on a container.
Okay, and I guess the key here is what the generative AI does is it allows people to use natural language versus having to actually know a lot of the commands.
Exactly. Not everyone's going to know exactly how to use the drone SDK.
Yeah.
They're not going to be well trained, but the large language model enables regular people to operate complex machinery.
Okay, so this really democratizes the use of it.
Absolutely.
All right, so you ready to give me a demo?
I think so.
Okay.
All right, we're going to get started with the game. Right now, things are just getting configured. And here we have our mini map as well as the feed of what the drone sees. So each drone is equipped with a camera, and that's how we are going to be scanning the QR codes that will tell us where we are positioned. So I'm just going to hit the takeoff button, and that's going to send the drone flying. There we go.
And up it goes.
Absolutely.
It's like magic, right?
A little bit. So what's going to happen now is the drone's going to calibrate itself. It's going to start looking down. Soon you're going to see the camera flip down to the floor to read the QR code. There we go. Now we are ready to get started. So what I'm going to do now is I'm going to show off
So what we're seeing on the screen is the camera from the drone.
Yes, absolutely.
Okay.
So that what we see now is what the camera sees. So right now I'm going to send it a command. So this is our mini map. This is how we know where we want to go. So I'm just going to say something simple like go to 10, and we're going to hit send. And that sends a request to our large language model. The large language model just sent us back some machine instructions that we can send to the drone. So right now it's just going to rotate to the right and then execute. Double tap, there we go. And as we can see here, the drone is starting to rotate.
Oh yeah, that's really interesting.
Yeah.
So you could even use this, like Amazon's been trying to do package delivery, things like that.
Yeah, exactly.
Yeah, there's a lot of use cases. for
Yeah,
this.
a lot of use cases you can think of.
Emergency services.
Absolutely, yep, like medicine as well.
Yeah.
So now
Not just Amazon packages.
Yeah.
But
All
some people
sorts of
think that's
things.
more important.
Yeah. So we just finished our first command. We're going to execute the second one, and now we're going to have our drone move. There we go. And now, this is the gamification aspect of this.
Yeah.
We now have a question on the screen that's asking us, are these bridge columns in good condition? This is just to essentially capture our imagination. You can imagine yourself as a bridge engineer and you're trying to perform an inspection here. So these do look good, so I'm going to say yes. All right, and now off to the next command. So I'm just going to say go to 3,1. Let's see how that performs. Awesome, we got us some commands, so let's execute that.
So those bridge columns weren't in any major U.S. city if they're in good condition.
We can say that, yes. There we go. And for the gamification aspect of this, we have essentially 4 inspection points and 3 minutes to get to all of them.
Okay.
Yep.
We probably don't need to go through all of them, but
right.
But I get the point here.
Absolutely. There we go. And next one. This is going to take us to the next inspection point. There we go. Are these in good condition? I think so. And we got some more points. So now we're going to navigate to go to 3,2. Send. Amazing.
It works.
It works. It works. Now let's try for go to. We might run out of time here, but 2,3 send. Sending to the large language model, and it's going to send us back some instructions as well.
Okay.
All right, but that's the end of the game. We ran into 3-minute mark. That's how much time each player is allotted for the demo.
All right, great. All right, Joseph, we're back from doing the demo. Thanks, that was fascinating.
No problem.
And I think that's a great use case of edge computing and generative AI coming together. Something that typically would have been a lot more technical for people to use, now can be done with natural language.
Absolutely.
All right, so Joseph, thanks very much.
No problem.
Okay, well, I switched locations here. Now I'm in the industry section of the reInvent demo areas, and I'm here with John Jenkins.
Yeah, great to meet you.
Yeah, and we're going to be looking at something called Amazon One.
Yeah, Amazon One Enterprise. So this is something we just launched, targeted at enterprises that want to have authentication for the employees that work for them.
Okay, so typically what happens if you work for an enterprise, you get given a badge. You come in and you scan in your badge everywhere.
Exactly,
right?
yep.
And so this solves that problem, right?
Sure, so like you might have a badge a lot like this one with your picture on it that you use to get into an office.
And if you forget it, you got to go all the way home.
Exactly, you're locked out or you have to go back to the badging office and then they have to issue you a new badge, which is complicated.
Down,
Exactly.
And if you leave it at your desk at lunch and you go out, you got to go to the badging office. Right?
Exactly,
so,
yep.
I think we've all done that before.
Exactly, yeah. So we're trying to solve that problem. If you think about a traditional sort of badge, it doesn't really prove who you are. It's a thing you have, right? If I give you this, all of a sudden, you are me, right? And you can get into the office building, and that's no good.
And in fact, I've heard with companies that have put in office mandates, people give each other their badges so they scan, so,
exactly. And then, the other way people solve it is with like pin pads by doors, right?
Yes.
Well, if you do that, it's again, not who you are, it's what you know.
Yeah.
So this is what you have, that's what you know, but really we care about is who you are.
And frankly, those aren't very hard to copy to.
Exactly. And so what we've done is we've solved the who you are problem using this Amazon One device. So to enroll, you would do something like the following. You would take your existing badge, you hit get started here, scan your badge, hit OK to a couple terms of use, and then hover your palm over. Now my palm is effectively a replacement for my badge, so I don't have to worry about losing this thing, I don't have to worry about someone else stealing it, etc.
What about cutting your hand off?
There's actually liveness detection for palms,
There is?
so
okay,
so got to keep it on your palm, or on your wrist.
Because you always see that in the movies, so don't worry about that.
As you can see, now that I've scanned my palm, I have the ability to go to, say, a door with an Amazon One scanner on it, hover my palm over the scanner, and as you can see, it's granted me access to this door.
Very nice.
But because I only scanned my right palm when I registered, if I use my left palm and try to go here, get it sort of straight, you'll see access was denied because this isn't linked to my ID. And so what it does is...
Can you scan both hands?
You could scan both hands when you register, so either palm would work. And so this is a really secure way to enable access control in a building. Much more secure than traditional forms like badges or even iris scanning. So it's 99.999% 99% accurate.
Oh
So,
wow, I didn't
yeah.
know that. What's iris scanning effectively?
The effectiveness of it is lower. I don't know the exact number offhand, but substantially lower than that.
All right,
So,
well thanks, that was a great demo.
Yeah.
So now we're going to go over and you're going to show me Just Walk Out, right?
cool, yeah, I can share that.
Okay, John, well we're here in front of this mock-up of a Just Walk Out store. I've seen these actually in airports and stadiums. For those who aren't familiar with Just Walk Out, what is Just Walk Out?
So Just Walk Out is a sort of new store concept that we came up with to do away with the lines that you would normally see at a store.
I hate lines.
So yeah, if you've ever been to a sporting event or something like that, you might have to wait in line for 5 or 10 minutes to get a beer.
And then you
we
miss
make
all
that
the
line go to
exciting
zero.
things.
Exactly. You
Yeah.
want to be in your seat watching what's going on in the
Yeah.
game. And so we built this store in order to do that. And so it's very simple. I can enter this store just by hovering my palm over this Amazon One device.
All right,
the
so-
gate opens. We can step in.
We go in.
Now that we're in, we're both in together, so we're shopping on my credit card, so you can buy whatever you
Okay.
want here. But there are some cameras up in the ceiling. Those cameras are looking at what we're doing, and when we enter into a product space and take a product off a shelf, it creates a virtual shopping cart. And that virtual shopping cart contains all the things I have. When I put it back on the shelf, the item is removed from my virtual cart.
So this is something people have asked me about Just Walk Out. Does it use RFID chips? You know, how do they tag the devices? But it's all camera technology.
Correct. So
Yeah.
we have cameras here, and on some shelves there are shelf sensors that help us judge the number of products that may have been taken. So you can imagine for a very small item, it's hard for a camera to see
Oh, yeah.
how many things I might take. So a shelf sensor can solve that problem.
Oh, so it actually knows by weight.
It does in this
Oh, that's
case.
interesting. Okay.
And so
I wondered about that myself.
yeah, whatever you and I take, as we exit through the exit gate, it will total up our virtual cart and charge the credit card associated with my Amazon One ID.
All right. Well, I need some chapstick.
Absolutely.
And
you know, in a Just Walk Out store, there are things that might feel like stealing, but really they're perfectly acceptable. It's perfectly acceptable to go into an Amazon One store, stick things straight into your pocket and walk out, and we'll get your receipt right.
and then there's a display in here that actually does it tell you?
Yeah, so we have a kiosk in here. If you want to receive a receipt, you can sign up with your email address so that we'll email you a receipt just as you leave the store.
All right. That was fascinating.
Cool, yeah.
Thanks.
It's a really neat way to shop, and more than 200 of these stores live now
That's-
in the US, UK, Canada, and Australia.
And so just give me an example of where people might find these. They happen to be traveling around the country.
Yeah, so we have them in stadiums all across the country. You'll find them in many airports. So our partner Hudson runs a bunch of stores. Colleges and universities, medical facilities, convenience stores all over the place.
Places where you get a lot of lines.
Absolutely.
Okay. All right, John. Well, thanks for the demo.
Thank you.
Appreciate it. Look, John, well, we switched stations here, and
Yeah.
it looks like we're at a restaurant kiosk. It's making me hungry, actually. So,
Nice.
Yeah. So what are you showing here?
Yeah, so what we're showing here is the ability to very quickly sort of pull up your past orders and attach your loyalty information to an order at like a quick serve restaurant. So let's say you were going to your favorite restaurant, you wanted to just place an order. You can hover your palm over the Amazon One reader here. It's going to pop up a screen. It's going to say, hey, you know, welcome back. I'm going to say I want to dine in. And what you can see is it's pulled up my previous orders already. So if I just want to reorder, I could very quickly check out right now. But let's
Are
say
these the price at the Amazon place? 1 cent, 1 cent.
you know, we have good prices
Yeah.
here at reInvent, so everything's going to reinvent. And so if I wanted to at this point, I could effectively, you know, just check out or add something to my order if I wanted to. There I've added the items to my order. I can now check out. You can see that here's the price that I have to pay. If I want to redeem my loyalty points here to pay for my order because it knew about that from my
Right,
palm,
right.
I can redeem my loyalty points, continue, and it'll print out a receipt. So it's a great way to quickly attach your loyalty information to your palm and your payment information to your palm so that you can place really quick orders at a restaurant.
Oh, you've got the receipt.
And I've even got a receipt here.
So this is the same technology that we saw before, just different use case.
Yeah, the same underlying technology that builds our Amazon One for Enterprise works in this consumer setting as well.
Okay, great. Okay, the sign here says age verification, so I'm guessing we're going to be verifying age.
Exactly. So, you know, a pretty typical problem at, say, you know, a food store at a stadium or something is you want to order a beer, right? So you got to get out your wallet. Oops, my ID's stuck in here, so I got to fish it out. So we asked,
And
how
then the
can
guy looks at it and tries to do the math in his head.
Exactly.
Yeah.
And so we asked ourselves, like, what could we do to make it easier to verify your age in settings where you need to do that? And so in my case, I've attached my age to my palm with Amazon One. So at a bar, I can quickly walk up to an Amazon One device, scan my palm, and the bartender would see a readout on their screen with my picture indicating that I'm over 21. So in this setting, it's very easy for them to make sure that they're only serving to people who are of legal age.
And if they weren't 21, it would just show up red.
It would show up red, and this is a perfect case where you can't hand your ID off to someone else so that they can, you know,
Right,
use your
yeah.
ID. So it's really a much better experience for both the user, because I don't have to fish my ID out, and the merchant, because they are far less likely to serve someone underage.
So if we were to see these technologies combined, you know, for instance, at a stadium, right, where you wanted to buy a beer but then pay for it at once, you could actually do it all in one, right?
Exactly, yes.
Oh, that's fascinating. Good.
So yeah, it's a perfect way to make things easier for both the merchant and the customer.
Good. Okay, well, we're here in a different part of the industry displays. I'm here with
Jim Huang,
Jim from-
Principal Solution Architect with AWS Telecommunication Business Unit.
and Julie McRae. You're not with AWS.
Yeah, I'm the CEO of Open Sesame, creator of SyncStage.
Okay, and so what are you guys showing here?
This is a real-time remote music collaboration. In this case, two guitarists, one playing on the floor here, another guitarist is playing the music in Los Angeles. And this is about remote music collaboration using technology, 5G quality of service, and AWS multi-zone computing.
So this is actually live. He's actually physically collaborating with somebody, and it's not a recording.
Yes.
Yeah.
Yes.
Okay. And then what does Open Sesame do? Just for people who don't know the company.
So Open Sesame built SyncStage, so we're the fastest audio pipeline on the planet. We send audio so quickly it allows you to do the synchronous group experiences like sing together and jam together. I think it's an important thing because we're in the telecom bit that when we talk about 5G, two things that your audience might know about is bandwidth or latency. We're showing a use case of ultra low latency, and that if you can do that, what that then enables in music, gaming, broadcast, and metaverse.
Okay, and just so people understand, we're in Vegas, he's in Los Angeles, so that's not a huge, but it's still a distance. And typically, even if you were to do a video call, you would notice, like a Zoom call, you would notice a little bit of a lag, right?
Yeah.
But you can't do that with music.
Yeah, so a typical video call that you're on will be about 300 milliseconds, okay? That's your Zooms, your Google Meets, and so forth. To be able to play together, you're needing to do 15.
Okay.
15 to 30. So something like SyncStage is like 8 times faster than WebRTC, twice the level of audio quality. It's built for this in partnership with AWS and Verizon.
And technically, how are you doing that?
Good question. How it happened? How we can make this solution work? So I may go through a diagram to show to describe.
Move the mic up.
So let me just turn this so people can see.
Sure.
So the question is how this happened. What are the technologies behind this solution? First of all, we have multi-edge cloud computing, where in this diagram you see there's a wavelength, AWS wavelength zones deployed in Las Vegas metropolitan area. The other wavelength zone is in Los Angeles. And the other technology is the SyncStage software deployed in the wavelength zone in 2 locations, which synchronize the audio traffic. The third technology is the Verizon QoS API, where we apply the quality of service at the RAN access network segment in each of the locations. And the fourth one is the interconnection of the 2 zones through Verizon network backbone, which gives extremely short latency, under 7 milliseconds. The 4 technology combined to make this remote music collaboration possible. So now is perhaps the time to listen to the music collaboration. You can try it out with your headset.
All right, so it's demo time now, and so who do we have here? You are Ryan.
I'm Ryan Scott. This is Jeffrey Lyle. We're just gonna play. We've been playing some stuff you might know.
All right, and so you want me to throw the old headphones on and have a listen? Yeah. Okay, let's go.
1, 2, 3.
Do I have to dance?
No, I wanna fall in love. So yeah, this kind of
that was
we're
awesome.
able to do this in real time and on time at a distance.
Great. And so how did this idea come up? You use this a lot?
I would use it a lot.
Yeah.
I probably would use it a lot.
All right. Well, I appreciate the appreciate the demo, Ryan. Thanks. I'm here now with Henry Wang at the NFL NextGenStats. as a big fantasy football player and NFL fan, I'm really looking forward to this one. What are you showing here, Henry?
Awesome, welcome. Hey, so we're showing here, it's a game that's inspired by some of the demo or some of the stats we have built together with NFL NextGenStats team.
So what are NFL NextGenStats? Anybody who watches Red Zone knows, but perhaps people who aren't fans, explain what those are.
Yeah, so NextGenStats, it's an internal initiative, right? That's really leveraging the data to bring the game viewing experience to the next level. So this initiative that our AWS team has been working with NFL team since 2017. So the NextGenStats team has been leveraging AWS infrastructure for taking all the data coming in from the player. So you have RFID.
I wanted to ask about how are you collecting that data?
Yeah, so you have the IDs, those sensors.
RFIDs in the shoulder pads.
RFIDs installed in the shoulder pads, their jerseys, their helmets from the players, and those data are being streamed in 10 seconds or 10 frames per second. Yeah.
And so that's how, on Red Zone or things, they know that, for instance, DeAndre Hopkins runs 26 miles an hour.
Yeah,
things
exactly.
like that. It's off those shoulder pads.
Exactly.
Yeah.
So you get the speed, acceleration, orientation, all kinds of these data sets.
And just give us how many data points would you collect during a game?
Yeah, that's a great question, but think about it, a lot of data. Yeah. So if we do a quick math, 10 points per second from each sensor, and every player have about 20 sensors on them.
Yeah.
So 22 players.
Wow, that's a lot of data points. Yeah.
Ocean of
and
data.
then the data, is that used by obviously the fans get to enjoy it, seeing it on the screen, but do the teams use it themselves for coaching purposes, strategy, things like that?
Yeah, that's a great question. So NextGenStats team right now collect all those data, and I do believe that they share those data with the team. But how do each team use the data? It totally depends on how they're working.
Okay, so you've built a game here, right? We're going to play it?
Yeah, of course. Let's dive into it.
Okay, let's do that.
Yeah.
So before we get into the game, can you give me a bit of the history of NextGenStats and how this came about?
Yeah, definitely. So our team worked with NextGenStats, and every year we together brainstorm about what we want to build for next year's NextGenStats, right? So NextGenStats team hold these global big data bowl competitions where people around the world can submit and enter through this competition. We have people coming from various backgrounds, like the college students.
So they might not even be football fans.
They might not, but most of them are.
Yeah.
But you have analysts, say, working from sports analytics team. You may have some other devs, and mostly enthusiasts, right?
Yes.
Want to be working on those, and even some coaches as well.
Oh, that's interesting.
Yeah.
Okay, yeah.
Yeah. So basically, there's a set theme every year for the Big Data Bowl. People enter through the competition.
A big data bowl.
A Big Data Bowl, yes.
Yeah.
And then out of all those, there will be winners selected, and the winners got both a money prize as well as a chance to go present those submissions to the NFL team, NextGenStats team. And then basically after submission, like the NextGenStats team will look at, okay, what are the interests from the community,
So
right?
this is crowdsourced NextGenStats. That's awesome.
There's a lot of wisdom of the community
Yeah.
going into this, for sure. Yeah. And then they will pick a couple ideas and we will brainstorm together saying, okay, what ideas do we want to be building, right? 1 to 2 stats that we want to enhance the fan viewing experience for this. And then our team will be building those stats together hand in hand with the NextGenStats team for 8 to 12 weeks. And then throughout that process, we do a lot of iterations together. We marry their domain expertise in football with our machine learning and artificial intelligence expertise. Our team is called a GenerativeAI Innovation Center, and we have worked with a lot of sports customers building these fan engagement stats. So this relationship with NFL has been really fruitful.
Okay. So ready to play the game?
Yeah, absolutely.
Okay, so show me the game here.
Yeah, so what you're seeing here is a game called Defense Decoder or a Blitz Probability Predictor.
Okay.
Right? So you are put in the suit and a helmet of a quarterback. You pretend to be the quarterback. And in front of you gonna be a defensive lineman. And you're trying to look at their movements. You will be assisted with a machine learning model that's collecting sensor readings from those IDs or chips. That's giving you their XY coordinates, their heartbeat rate, their body temperature, etc., and try to give you alarm and eventually an estimated probability of whether a certain player is coming, going to blitz.
87% probability of blitz.
Yes,
That's,
so that is a tutorial,
Yeah.
and now we're going to go to the actual game playing.
Okay.
So you have 3 sides, the left, the center, and the right.
Okay.
And based on those, what you're observing as a quarterback, you need to pick one or multiple sides where the blitz might be coming from. So for example, I'm seeing, okay, the right side seems like there's some direction or pointing over here. I'll make a guess and say, okay, the right side is where, okay, somebody's actually rushing me. I got that correct. So this give me a 12 yards gain.
Oh,
Yeah.
great.
And
First down.
First down. First down. So I have 50 seconds left on the clock and 38 more yards to go. Okay.
You better run the hurry up.
For this one, okay, I see some left movements. I really want to get a little bit help from the machine learning model, right? Let me see if, okay, I'm getting some alarm from the right side as well. And okay, I see the full probability of them hiking towards me. So seems like the left and the right were where the models were thinking the blitz coming from, and I selected those. So this is a futuristic looking into how those data could be potentially used for decision making, but right now it's mainly used for educational purpose to engage the fans, etc.
Okay, now what if you got one wrong?
If I got them wrong, then I got sacked and I lost yards.
Okay.
Yeah. So another feature is that I have a timeout for 10 seconds where all the sensor reading real time will be showcased to me. And in this way, I can really use them strategically and pick the right one. So in this case, I'm actually getting a whole lot of readings from the sensor, a lot of information from the machine learning model.
Because they're bringing the house.
Yeah.
But you
So-
beat the blitz.
I beat the blitz. Let's see the last one, how many yards I have. 22 seconds, 15 yards. Okay, I'm a little bit short on time. Let's see if I can get this. Right, left. Okay. All right, perfect. I got this one again. Well, I got
Touchdown.
a touchdown. Perfect. So they show you the stats of my blitz probability accuracy being surprisingly, amazingly 100% today. So got a really good hands today and good reading.
All right, Henry, that was really fun. So maybe you're ready for the NFL now, huh?
Oh, 100%. Anytime now.
Yeah. Okay. Well, there's a lot of injured quarterbacks, so maybe you can make your way in there.
Yes.
Just take your
We'll
next
see.
stats
Yeah.
with you.
Look for me on the course, okay?
Okay.
All
Thanks,
right,
Henry.
cool.
Appreciate it.
Cool. Thank you.
All right, so this is my last stop on the ZKTour. I'm here with Alina Dima from Amazon. We are in an area that you're calling open source auto Las Vegas style. So explain what that is, Alina.
Yeah, right. So here we are seeing a demo made of 2 parts. So here we have a driver cockpit and a Grafana dashboard.
Okay.
So the driver, the car is in autopilot mode.
Yeah.
So what you will see is as the driving happens, you are going to see on the dashboard signals such as vehicle pressure and vehicle speed, throttle positioning, position, steering position, as basically the real-time events as the driving actually happens. So, for example, if the car would stop at a traffic light, you would see a correlation between the traffic light stop and a high brake event on the chart.
Okay. And then how
Yes.
might this data be used?
So this data is made available to customers, and customers can use it to support use cases such as improving vehicle health, vehicle monitoring, or use cases such as advanced driver support and autonomous driving, and improving maybe the driver experience as well.
Okay.
So what you see in the demo is a service called AWS IoT Fleetwise,
Okay.
which helps customers collect, transform, and transfer data coming from their vehicles to the AWS cloud. Additionally, a very important aspect is that we are using a service called IoT Core, which supports the secure connectivity to the AWS cloud.
Okay, and then the customer in this case is the auto manufacturer, an auto insurance company, the actual driver of the car.
So the customers are automakers,
Okay.
but of course, I mean, the service, once the data is made available, the data can be used by customers in various use cases, right?
Okay. So an insurance company can actually monitor how somebody drives and maybe change their insurance rates if they're an aggressive driver or a safe driver.
Possibly,
Yeah, okay.
yes. So one thing that's very important is that the data is stored securely on the AWS platform and made available to customers for their use cases.
Okay. So why don't I hop in, have a drive, and we'll see how things change.
Yes, sounds very good.
All right.
So down there, acceleration and brake in the middle.
Yeah.
And
Okay.
give it a spin.
Oh, wait. I turned too wide there.
Yeah.
Okay, there. Oops, I hit the curb.
So you can see a collision intensity event here on the left-hand
Oh,
side
that's what that
as
is,
you
okay.
collide, yes.
I went through the red light, or yellow
You
light.
will see this here as well. So here we have signals coming from the CAN bus. So all this is, CAN data.
Okay.
Right down here we have, of course, as the data changes, you can see the max, you can see an average, and you can see also the minimum.
All right.
And of course, here you also can see the average values for the particularly selected time in a table. Yeah, so another thing that we're actually doing is on hard brake events, we are also allowing for sensor data to be gathered, and this sensor data can actually be also shown here on the chart. So at the moment, I think there was no hard brake event because we stopped.
Oh yeah.
So we could go back in autopilot mode. So basically you can see
That's
images.
right. I didn't use the brake either, so.
Yeah, so it's usually only if the hard brake event is over 16K.
Okay.
This is something that is configurable with the service.
All right, Elena, thanks. That was a great demo. We had a combination of cloud computing, IoT, some analytics, right? Thanks. That was an awesome demo.
Thank you very much for popping by.
Thanks. Well, that wraps up the ZKTour. I hope you enjoyed it. AWS is certainly doing some interesting things, and it was great to see it on display here inside the Expo Hall at AWS 2023 in Las Vegas. Make sure you hit that subscribe button, and I'll see you next year at reInvent 2024.